Binary to decimal conversion.
Hello everyone, welcome to this video series, and in this video I'm going to be teaching you how to convert from binary to decimals. In the previous video we looked at decimals to binary, but now we're going to be looking at from binary to decimals. So if you have binaries like for example 01100, what is the decimal equivalent? So how do we know? So it still starts with us knowing our multiples of 2 table of 2 to the power of 0, which is 1, 2 to the power of 1, which is 2, to the power of 2 is 4, to the power of 3 is 8, and on like that. So you have to know your multiples of 2s to find it easy calculating all of this. So now let's take this as an example. We have 01100. What is the decimal equivalent of that? That means 1, 2, 3, 4, 5, 7, 8, 9, 10 equivalent of these zeros and 1 that we can see together. So now we're going to put our 1A, our 2, our 4, 8, 16. Yeah. So now for us to get the decimal equivalence, we're just going to add wherever we have our ones together. So the decimal equivalence of this is going to be 8 plus 4, and that is 12. So now let's try to make it a bit complex. Let's say we have 1110. So it still starts with, we have to write our 1, 2, 4, 8, 16. So we start with 1A, then we have 2, 4, 8. So we can stop at 8. So now we're going to have 8 plus 4, which is 12, and 12 plus 2, which is 14. It's easy peasy, as simple as ABC. So for example, now let's take 14 back into binary. So if let's want to take 14 back into binary, we have to start with 8 because 14 comes in between 8 and 16. So we start with 8. So we have our 8, 4, 2, 1, 0. So we start with 8. We put 1 here. 14 minus 8 is going to give us 6. So we can have 1, 4 in 6. So we can have 14 minus 8 was 6. So here we can still have 1, 4, like I said, in 6. So we can have 1 here. And then we take away 4. We have 2. So we have 2. So and then that's it. So you can see 1110 back to where we were coming from. So you can see it's easy. So now I'm going to try one more example, and then I'll convert the binary to decimal and then convert back from decimal to binary. So let's say we have 0, 1, 1, 0, 1, 1, 1. Okay. So we still start from our 1, put our multiples of 2. 2 raised to power 0 is 1. 2 raised to power 1 is 2. 4, 8, 16, 32, 64, 128. Because 2 to the power of 7 is 128. Okay. So then we add wherever we have ones all together. So we can add 64 plus 32 plus 8 plus 4 plus 2 plus 1, because that is where we have the ones being represented. So 64 plus 32 should give us that is 96. 96 plus 4 should give us 100, and then 108, 110, 111. So we have 111. So let's say we want to convert 111 back to binary, and let's see if we're going to get exactly what we have here. So now 111 comes in between 128 and 64. It's not up to 128 like you can see, and it's more than 64. So we start with 64. So we take 111 here and we deduct 64 from it. But before we deduct 64, let's start by writing our multiples of 2's here so that we can put our 1's under them to convert them to binary. So we have 64, 32, 16, um, 8, 4, 2, 1. So now we can have 164 in 111, and if we deduct that, we should have, we put 1a, then if we deduct this, we should have 7a, and then 4a, that is 47. Okay, so in 47 we should still have 32, so we can put 1a and deduct 32, so we can have 5 and 15. So in 15 we can't have 16 in 15, so we put 0 here. We can have our 8. So if we deduct 8, for example, from 15, we can have 7 left. So we're going to put 1 under 8 because we put 1 under the numbers we are deducting. We are able to deduct from that. So under 7, we can deduct 4, and that should give us 3. And under that, we can have our 2 and 1 in 3. Okay. And 1 minus 1 should give us 0. So now you can see that it's easy peasy now because we are able to get our binaries from deducting the multiples of 2. So this should give us 110 1111, and that's exactly where we started from. A. Okay, so it's easy to convert from binaries to decimals and from decimals to binary. Thank you.